Hello, AI enthusiasts. Welcome to a new deep dive. Building on our previous talk about principal component analysis and how it helps us reduce dimensionality, we can now see how understanding the normal structure of data allows us to detect the unusual. Most videos on anomaly detection focus on complex math, but skip the core challenge of defining what is actually normal. In this video, we want to show something different. The struggle of the night watchman who must learn the factory's rhythm before he can ever spot a single broken machine. Imagine a night watchman starting his first shift at a massive factory. He does not know what is broken because he does not yet know what is working. To find an anomaly, he first has to spend weeks listening to the hum of the engines and watching the steady pulse of the pressure gauges. This phase is what we call learning the normal profile. In data science, we cannot define an outlier until we have a rock-solid model of the typical behavior. Let us look at a single gauge on the wall. If the needle stays between 10 and 20, the watchman stays calm. This is univariate detection, where we monitor just one variable at a time. It is like checking a person's temperature. If it goes too high, something is wrong. However, life is rarely that simple. The watchman learns that looking at one gauge in isolation can lead to false alarms. Now, imagine the watchman monitors two gauges, heat and speed. On their own, both might look fine, but the watchman knows that if the machine is running slow, it should be cool. If it is slow but burning hot, that is a multivariate anomaly. Think of it like a seesaw. Both ends being off the ground is normal, but both ends touching the ground at the same time is impossible. We are not just looking for values that are too high or too low, but for relationships that have been shattered. The hardest part for our watchman is deciding exactly when to sound the alarm. If he is too strict, he will be awake all night chasing shadows and false leads. This is the boundary problem. In data science, we create a mathematical fence around the normal data. If the fence is too tight, we catch everything but suffer from noise. The watchman must find the sweet spot where the boundary captures the essence of normal. What happens when the factory upgrades its equipment? Suddenly, the old hum is gone, replaced by a new, higher-pitched whine. To the watchman, this looks like a massive failure, but it is actually the new normal. This is known as data drift. Our models must be able to evolve. Think of it like a watchman who has to learn that a quiet factory on a Sunday is not an emergency. Not every wiggle of a gauge is a crisis. Machines vibrate, electricity fluctuates, and sensors have glitches. The watchman's greatest skill is distinguishing between the random static and the meaningful signal. Think of it like a crowded restaurant. The clinking of silverware is noise, but a scream is an anomaly. We use statistical smoothing to ensure we are not jumping at every shadow. We focus only on the events that truly deviate from the collective pattern. The most powerful part of this process is that the watchman does not need a manual. He just needs to know how it looks when it is healthy. This is unsupervised learning. By clustering normal behaviors together, the anomalies naturally stand out because they have no friends. They are the data points that live in the empty spaces of our map. We teach the model what a perfect pump looks like and let it figure out the rest. A factory has thousands of sensors, but not all of them help the watchman. Choosing the right features is critical. We use techniques like PCA to condense thousands of gauges into the few that actually matter. By focusing on the variables that represent the most variance, we make the watchman's job easier. It is about finding the signal in the forest of information. Today, the night watchman is an algorithm running in every credit card transaction. DAST. Whether it is spotting a fraudulent purchase or a failing satellite, the principle remains the same. Learn the normal, define the boundary, and stay alert for the unusual. By mastering the profile of the ordinary, we gain the extraordinary power to see what others miss. Thank you for joining us on this watch. Subscribe to keep exploring the hidden patterns of our world. Subscribe for more deep dives into data science using simple analogies.